Okay, so here we're going to prove the parallelogram theorem, and it basically says that if it's a parallelogram, then opposite sides and opposite angles are congruent. I stated slightly different here, just in a more way to look at a diagram with it. So it says if ABCD is a parallelogram, then it gives us the result. It tells us that the opposite sides, this side is congruent to this side is going to be congruent to this side, and opposite angles are congruent. 1 will be congruent to 3, and 4 will be congruent to 2. I'm only going to prove that one pair of opposite angles are congruent, but it's easy to just draw a different diagonal. So if you draw the other diagonal, there's 2 diagonals in a parallelogram or any quadrilateral. This is one of them. I'm going to draw this one, which will prove that 2 is going to be congruent to 4, but I could have drawn the other one, which would prove 1 is congruent to 3. Now, to prove that everything, which you have here, is you just essentially show that these 2 triangles that now you've isolated are congruent, right? So you just show that this triangle over here is congruent to this triangle over here. And then once you prove that they're congruent, then all the corresponding parts are congruent, and all of this will fall out. So that's your theory, right? Now let's start going through this. Let's see what we have here. So now I'm gonna look at this. Now I see that I broke up angle 1 into 2 angles. I'm gonna call it, I don't know, angle X and angle Y up here. I'm gonna call this Z and then this W over here. Okay. How am I gonna prove these 2 things congruent? Well, what do I know? I know that ABCD is a parallelogram. But what does that mean? Right? What information does it being a parallelogram do I get, right? And what I get is that the opposite sides are parallel. So I know immediately that BC is parallel with AD, and I know that AB is parallel with DC. Okay, and that's definition of parallelogram, right? Both pairs of opposite sides are parallel, then it's a parallelogram, okay? And it needs to, of course, be a quadrilateral. Okay, definition of parallelogram. And what this allows me now to say, since these lines are parallel, right? If we look at this line here, BC, and we look at this line, AD, we know that they're parallel. And you can look at this line like a transversal. And what that guarantees is that Y is congruent to Z. Now, why is Y congruent to Z? Well, let's see. Angle Y is congruent to angle Z. Take your time, sit here, figure out how we can guarantee that Y is congruent to Z. We know that because of alternate interior angles theorem. And we couldn't use this theorem, interior angles theorem, okay. We couldn't use this theorem if these 2 lines were not parallel, because what does the theorem say? It says that if the lines are parallel, alternate interior angles are congruent, right? So we couldn't use this unless we knew that these 2 lines are parallel. These 2 lines are parallel, so then therefore alternate interior angles are congruent. Y is congruent to Z. Similarly, if we look right over here at this line and this line, they're parallel. We know that. Then, and if we look at this as our transversal and we tilt our heads, or if we don't need to tilt our heads, it's great. We can see that X is going to be congruent to W. And I'm going to write that on the same line because it follows from the same reasoning, alternate interior angles theorem, but we're using a different pair of parallel lines and a different transversal. We're using this. Wait, are we using a different transversal? No, we're using the same line as a transversal, but a different pair of parallel lines. So it's this line and this line. And then we're taking this as the transversal again, and we should see that X is alternate interior with W. 4. Now I just state that this diagonal, BB, I'm going to outline it in a different color, BD is congruent to itself. And that's reflexive. now we should see that we have our end goal. We have that these two triangles are actually congruent, because I have this angle congruent to this angle, then I have x congruent to w, and the side between them, this side, is congruent to itself. So this triangle is congruent to this triangle. So I have that the triangles are congruent by angle, side, angle. Right? If you need to pick apart the two triangles, flip one around and see that it's going to be angle. This angle is the same as this angle. This side is the same as this one, and then this one is the same as this one. This side is the side between the two angles, so it's angle, side, angle. And I'm going to try and say it in the right way. I'm going to call this triangle BDA is congruent to, I think it's DBC, right? BDA, DBC. Yeah, BDA is this angle, and then DBC is this one, so they match. So yeah, it's going to be triangle DBC. And get the order right, because we are going to be using CPCTC, so it matters, this order. And we know that the two triangles are congruent because of angle, side, angle. 6. The next thing is we just start listing off all of our conclusions, and it's going to be because of CPCTC. So why is it that this side is congruent to this side? CPCTC. Why is this congruent to this? CPCTC, right? This side, right, is corresponding with that side in the two congruent triangles and so forth. And I'm just going to list off literally everything except for one is congruent to 3. I'm not going to put that one. So I'm going to say AB is congruent to DC. I'm going to say BC is congruent to AD. And then I'm going to say that 4 is congruent to 2. And this is all CPCTC. And we could have easily so I have one pair of opposite angles congruent. I showed that 4 was the same as 2, but I didn't show that 1 was the same as 3. But that's fine, because I could have just went all the way back, drawn the original parallelogram, and instead of taking this diagonal, right, this one, the one that I took originally, I could take this one, and then it'll show this angle is congruent to that one by showing these two triangles congruent. So it's not really worth it. We can convince ourselves that this should be sufficient to prove it. Also, I don't know, I'm supposed to say, like, I don't know, my students say like and subscribe.